Hello everyone, myself Supriya Bhosle, and in this video I am going to discuss addressing modes of 8051 microcontroller. So let us start. What is the definition for addressing mode? The term addressing mode refers to the way in which operand of an instruction is specified. What is this operand? We know that for every processor or a controller there are some instruction set, right? That instruction consists of a mnemonics and operands. That operands can be a source or a destination. So the way in which those operands will be specified in an instruction is called as addressing modes. So for 8051 there are 5 types of addressing mode. First one is immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and register indexed addressing mode or indexed addressing mode you can call it. So these are the 5 addressing modes for 8051 microcontroller. Okay, so let us discuss one by one. First one is immediate addressing mode. So definition for this one is if a data is immediately specified in an instruction, okay, then it is called as immediate addressing mode. So you can specify the data by its value and hash symbol. Okay, source is always a data. So this hash symbol is very important. If you do not put this hash symbol, then it can be considered as a address. So whenever a data or a value is there, you have to put a hash symbol. So this is for the immediate addressing mode. So for this addressing mode, remember that hash symbol is very important. So let us discuss some example. First instruction is move a comma hash 25h. So this is the instruction. Now move is a mnemonic. A and 25 hash 25h, these are the operands. Okay, so how you are specifying this 25h? So by putting hash sign, it indicates it is a type of immediate addressing mode instruction, right? So what this instruction will do? This instruction will move the data 25 hex to the accumulator. 25h is the 8-bit data and accumulator or most many registers of 8051 are of 8 bits. Okay, so you can store this 25h data into an accumulator. Then next instruction is move a comma hash 0. So 0 is moved or stored into the accumulator. Then move R4 comma 11 hash 11h. So 11h is the value that has to be stored into the R4 register. We know there are 4 banks for 8051 and for each bank 8 registers are there, R0 to R7. So here which bank we should not bother. Okay, so only just remember that the 11h is stored into the R4. Now move B comma hash 11. Here h is not specified. It means 11 is a decimal number and that value has stored into the register B. Actually the binary value is get loaded into the B. Okay. Then next instruction is move dptr comma hash 752h. For 8051, two 16-bit registers are there. One is the data pointer and second one is a program counter. So here 7521 hex, it is a 16-bit value. I have put hash sign, it indicate it is a data. So this data has stored into the data pointer register which is of a 16-bit. Okay. So this is about immediate addressing mode. Now next one is register addressing mode. When data is in register and register is specified in an instruction, then it is called as register addressing mode. Okay, the source and or destination is a register. Let us understand with the help of some example. First example is move a comma rn. N is for general instruction. Okay, rn. We have r0 to r7 register for each bank, right? So contents of data is stored where? In R register, and that register is specified here in an instruction, right? So that's why it is called as register addressing mode. Okay, register is specified, okay, and contents of that register are stored into another register. Next instruction is add a comma r5. This will add the contents of r5 with accumulator, and result will get back stored get back to the accumulator. Okay, so either source or destination is one of the CPU register. Here are few more examples. Move r0 comma a. This will move the contents of accumulator into r0. Move a comma r7. This will store contents of r7 into accumulator. Add a comma r4. This will add the contents of r4 and accumulator, and result will get stored back to the accumulator. Move r5 comma dpl and move r1 comma dph. As I said, dptr is a 16-bit register. Okay, so for that we are having two register to store the lower bytes and higher bytes of 16-bit. Okay, so for that dpl register is there, and for higher bytes dph register is there. So contents are stored, lower bytes are stored into r5 and higher bytes of dptr are stored into the r1. Now in this addressing mode, one thing you have to note that data transfer from R to R is not allowed. Okay, you cannot write instruction like move R4 comma R7 or R1 comma R3. Okay, it is incorrect instruction. It is not allowed. Okay, you have to store through accumulator, or you can store through another register. Okay. Next addressing mode is direct addressing mode. Here data is in memory location and address of memory location is directly specified in an instruction. That's why it is called as a direct addressing mode. I'll repeat this one. Data is stored somewhere in memory location and address of that memory location is directly specified in an instruction. Okay. For example, move a comma 25h. Now here you can note that hash sign is not there. That means it is not a data, but it is an address, right? So data is stored where? To internal RAM address 25h, and the contents of this memory location will move to the accumulator. Okay, so data, uh, this addressing mode specified data by its 8-bit address, and that address usually for 8051 it is from 30h to 7fh for of RAM. Okay, uh, here are some examples. Move a comma 70h. 70h is the address. Whatever the contents are stored at this location will get moved to accumulator. Then move r0 comma 40h. Copy the contents of RAM at 40h to r0. Then contents of accumulator will get stored to a memory location 56h, and move 0d0h comma a. So this is basically d0 is the address of program status word of 8051. So instead of mentioning this one, the address have mentioned, and this will move the contents of accumulator to the into the PSW register. Okay, so this is the direct addressing mode. Next one is register indirect addressing mode. Now, why it is called as the indirect addressing mode? We have seen register addressing mode, we have seen direct addressing mode. Now, here register indirect means data is in memory location and address of memory location is in register, and register ID is specified in an instruction. Means indirectly we are mentioning the operands. Okay, means data is somewhere in memory location, address of memory location is in register, and that register is indirectly specified in an instruction. Let us understand this with the example. What is this instruction? Move a comma at R0. So for indirect addressing mode, at sign is there, means move the contents of a memory location pointed by R0 into the accumulator. This is what the meaning of this instruction. So data is stored somewhere into memory, and address of that memory is stored into the R0, and that data which is pointed by R0, and you have to point this by at sign, that will move to the accumulator. Okay, so R0, or here for this addressing mode you have to use only two registers, R0 or R1. Other registers are not allowed. Okay, so first instruction here is move R0 comma hash 3ch. Now this value have stored into the R0. Okay, now next instruction is move at R0 comma hash 3. Now 3 is a value or a data, right? Now where it gets moved, where it is moving, it is moving to the memory location pointed by R0, and now this R0 is pointing memory location 3C. So when you put at sign, this will become a memory location. Okay, here 3C is some value have stored into R0, and this 3 data or a value have to be moved to where? A memory address or a location pointed by R0, which is of 3C. Okay, so 3 data will get moved to the 3C. So this is how indirect addressing mode, register indirect. For these two instructions are for 8-bit address. If you are using a 16-bit address, okay, in case of external, here you can see move dptr hash 0x9000. Here x is one way, x is nothing but it is hex data. Okay, this is also a way you can specify hexadecimal value. Okay, so 9000h have moved to the dptr. Now dptr is having the value 9000. Now whatever the contents or data pointed by this dptr will get moved to the accumulator. Okay, so here move x instruction have been used. Okay, and x indicate it is an external memory. Whenever the external memory you have to consider, we have to use move x instruction. Okay, so data is in memory location, address of memory location is in register, and that register is indirectly specified in an instruction. Okay, this is what register indirect addressing mode. Now last addressing mode is register indexed addressing mode. Now here data is in memory location, and effective memory address is calculated by adding the contents of accumulator to either data pointer or program counter. Okay, here base address is calculated, or you can say effective address of a memory location will be calculated by adding the contents of accumulator and data pointer or a program counter. Let us understand this with example. Okay, one instruction is there, move C A comma add A plus dptr. Okay, so A plus dptr, this will add the contents of accumulator and dptr, and a effective base address will be generated. Okay, now data is at that memory location, okay, which is pointed by this at sign. The contents of that memory location will get stored to the accumulator. Now here C is used as this is a code memory. Okay, X is there, then it is a external memory. Here this instruction, what it will do, this will move the contents of a memory location whose base address will calculated by adding the contents of A and dptr to accumulator. Okay, so base address, for base address it can be a dptr or a program counter. Base address will always be calculated by dptr and program counter, and here index is what, where it is in accumulator. In each instruction you can see A plus dptr or accumulator plus program counter. So the address will calculated by adding the contents of accumulator with dptr or program counter. Okay, here you can see first move dptr comma hash 4000h. This instruction will move 4000h value to the dptr. Now A is having the data 05x. Now what will be the base address? Obviously it is 4005h. So this is the base address. Okay, so A plus, whenever A plus dptr will be executed, this will calculated as 4005. Now this is the memory location, and the value present at this memory location will get moved to the accumulator. Okay, so this is register indexed addressing mode. So this all things are about all addressing modes of 8051. I hope you understand all these addressing modes. Thank you.